Hi folks, welcome back to the 7th and final video in the integration review video series. So we've got 3 last questions to finish up here, where we're going to continue to practice looking at definite integrals using U substitution, okay? So let's take a look at example 20. We have the integral from 0 to pi over 4 of secant squared theta tangent theta d theta. So as we start Calc 2, we're going to have a lot of integrals involving trig. But one of the things you should always look for first is, could it possibly be U sub? U sub is actually going to be easier than some of the other techniques, right? So it's about decision making, not just about doing the last thing that we learned. So in this case, I scanned through the integrand and I noticed that secant squared is the derivative of tangent. So I've actually got my U right there. U equals tangent theta. That means my du equals secant squared theta d theta. Okay? And that happens to match perfectly, how very nice, with the integrand. So all of that stuff in the orange, I can replace with du, and all of the stuff in the pink, I can replace with u. Now let's take a look at our bounds. The bottom bound is 0. So that means I need to find u of 0, or tangent of 0. Okay? Tangent of 0 is 0. Good things to know from your unit circle. Top bound is pi over 4. So u of pi over 4, not pi over 2, Judy, pi over 4 means that we have to find tangent of pi over 4. Now, pi over 4 is one of those angles where the sine is the same as the cosine, so that means tangent at that angle is 1. And so what we really have here, after we substitute everything in, integrand and bounds, is we have the integral from 0 to 1 of u du. Wow, that got way simpler, way fast. Now this integral is going to be 1/2 u squared, plugging in 1, plugging in 0. And that's going to give me 1/2 1 squared minus 0 squared, or a final answer of 1/2. Okay? So no matter what other skills we learn here, remember, it's about decision making. How do you know when to use what? All right? Okay, let's move on to example 21. All right. Let's pick our u. So I have a sine and a cosine to the 4th. This cosine on the bottom is going to be our u, and that means our du is negative sine theta d theta. Now I notice in my integrand that I only have a positive sine theta d theta. So I'm going to take that negative sign and I'm going to divide it over to the du side. All right, integrand taken care of. Now let's take care of our bounds. Bottom bound is 0. Whoop. Jumping ahead of myself here. U of 0 equals cosine of 0, which equals 1. And top bound is pi over 4. And u of pi over 4 is cosine of pi over 4, which is root 2 over 2. Okay? So we really want to make sure that we know our unit circle, so we're not just kind of guessing what value it is, but we can actually focus on doing the integration and doing that part correctly. Okay? So let's substitute everything in. Let's see what we get. I'm going to get the integral from 1 to root 2 over 2 of 1 over u to the 4th du. Now, we can't use our power rule right here. We have to rewrite it as u to the negative 4 du. Now we can use the power rule. So that is going to give us 1 over negative 4 plus 1, u to the negative 4 plus 1, plugging in root 2 over 2, and plugging in 1. That gives us negative 1/3 u to the negative 3rd, plugging in root 2 over 2, and 1. And I'm going to rewrite this one more way, which is negative 1 over 3u cubed, root 2 over 2, and 1. Okay? Now I can plug in my bounds. So negative 1/3. So when I plug in my u's, I need 1 over root 2 over 2 cubed minus 1 over 1 cubed. And that is going to give me negative 1/3, okay, 1 over 2 root 2 over 8 minus 1, or negative 1/3. Let's cancel some things here. These are going to reduce to a 4. So 4 over root 2 minus 1. And that is going to give us negative 4 over 3 root 2 plus 1/3. And it's okay to leave our answers like this, okay? All right, we've got one last example to work on here, and that is example 22. All right, these are all trig ones for a reason, because again, when we start our first unit this summer, we're going to be looking at a whole bunch of techniques, and a lot of those techniques involve trig, but we want to make sure we know, can I use u sub, or do I have to use one of the new techniques that we learned? All right, our u in this case is going to be the denominator, 1 plus cosine x. U equals 1 plus cosine x. That means du equals negative sine x dx. Now, same thing as the last problem. I look here and I only see a sine x dx. So I'm going to take that negative. I'm going to divide it to the du side. All right, so my integrand is done. Now I have to look at the bounds. So u of 0 means 1 plus cosine 0, which is 1 plus 1, which is 2. Top bound is pi over 2. So u of pi over 2 is 1 plus cosine pi over 2, which is 1 plus 0, or 1. Okay? All right, well, let's go ahead and substitute everything in, okay? So I've got negative the integral from 2 to 1 of 1 over u du. Now remember, this is our one exception to the power rule, and we want to make sure that we know this inside out because it's going to show up in a lot of different problems, okay? So I get negative the natural log of u. Now in Calc 1, it probably wasn't as important to put the absolute value bars, but it's going to be really important for us here as we kind of grow in our math skills. We want to be more and more accurate, okay? So I'm going to plug in 1, and I'm going to plug in 2. This is going to give me negative natural log of 1 minus natural log of 2. And this is going to give me a value that I really should know, which is natural log of 1 is 0. So I get negative 0, distribute this minus sign, plus natural log of 2. And that gives me a final answer of natural log of 2 as my answer. Okay? Now in this case, the absolute value bars didn't change our answer. But when we're looking at indefinite integrals and we have an expression with x in the end, it's actually really important to have those absolute value bars. Okay? So that's it for our integration review. I hope you found this super helpful as a way to kind of get caught up. No matter how long it's been since you took Calc 1, I hope this will set us off to be successful for Calc 2. All right, looking forward to a great summer. See you there.